Hello, welcome to the final presentation of Optimum FHIR. I am very excited to share with you what we have done for this project on behalf of this team. Dawn, Yasin, Reena, Austin, and myself, Joji. Before I get to the implementation details, let me just give you the context and goals we set out to achieve. Emory's radiology department uses Cerner as their primary IT platform. Cerner has limited scheduling capabilities as far as physician scheduling and resource management is concerned. For that reason, often physicians use other tools such as QGenda, which offers advanced capabilities for scheduling. Since they have two disjoint scheduling systems, integrating and keeping them up to date has become a challenge. It involves tedious manual work. For the past several weeks, we have conducted interviews and had meetings with people from Cerner, QGenda, and Emory about potential solutions. The meeting with John Duke defined our scope of the work. We found that Cerner has a smart on fire and they have a fire compliant scheduling system. So scope of this work essentially boils down to integrating QGenda with a Fire-based server. Now let's look at the implementation. This solution is implemented as a standalone independent service which periodically queries QGenda schedules for all the enrolled physicians. It then compares QGenda schedules with appointments from FHIR server and generate a delta. This delta will be updated to FHIR server. For performance reasons, we keep a local copy of the schedules for each physician in a local Redis database for further comparisons. Initially, physicians are required to be enrolled in the Optimum app so that we can match each physician's QGenda profile with their corresponding FHIR profile. QGenda is the master scheduling data source. Python was the main implemented language. We used frameworks such as Flask for Web UI and Cron, which is a time-based job scheduler to run integration job periodically. Emory can potentially host the service in the public cloud such as Amazon's EC2 or in their private servers. I also want to point out that we have built a generic integration system for QGenda. That means any fire compliant system can be integrated with QGenda using Optimum. The UI is hosted on a publicly available web server. It is designed for administrators to keep track of schedule synchronizations. Here is a screenshot of the UI where you can see the names of the physicians and number of tasks updated during the last previous sync operation. Here is the UI for Optimum FHIR application. You can see that currently 2 doctors are enrolled to receive updates from QGenda, and number of tasks updated is 0 because there was no change in schedules. Now let me go to QGenda and add a new schedule. This is for Dr. 1 on December 10, working task 1, start time 10:30 a.m., end time 12:30 p.m. Save, publish. Now let's go back to Optimum UI. We should see an update here. You can see that for Dr. 1, there is a task update. Let's go to FHIR server to make sure that a new appointment is added. You can see that a new appointment is created. This is for Dr. 1, working task 1, start time 10:30, end time 12:30. Thank you. Deployment instructions were added to project's GitHub repo in order to have a seamless handoff to Emory folks who are looking to pick up the project where we left it and deploy to Emory servers. Coordinating and getting in touch with Cerner and understanding Emory's Cerner integrations were certainly a challenge. However, a major challenge was to set up the initial seeding data and matching the physician profiles. Also, this system has three different Docker services that are talking to each other. We had some trouble getting it up and running in Georgia Tech servers and Rancher. Here's the updated Gantt chart. As you can see, we have completed all the tasks and documentation as per the plan. Thank you.